In this lesson, we're going to find missing angles of triangles. We're going to start out by talking about something a little basic. When you have variable expressions for each of your angles, and you know that the sum of the angles of a triangle are 180 degrees, then you set up an equation by adding all the angles. We're going to add x plus 2x plus 10 plus 3x minus 10 and set that equal to 180. You would combine like terms. We get 6x equals 180. Then we know x is 30. And once you know x is 30, you can find all three angles. This angle would be 30 degrees. 3x is 90 minus 10 is 80. And then this angle over here, 2 times 30 is 60, plus 10 is 70. And to double check, you just add them up and make sure they equal 180 degrees. In this triangle, we're given that this angle is x minus 20 and this angle is x plus 15, but we're not told anything about this angle over here. So then we need to look and see if we can figure out what kind of triangle it is. We are given that this side is 10 and this side is 10. And what we know about isosceles triangles is that they not only have two sides the same, but the angles opposite those sides are also the same. So the angle opposite this side is equal to the angle opposite this side. So since this one is x plus 15, this angle is also x plus 15. So then we'll set up an equation, x minus 20 for the top angle, plus x plus 15 for this base angle, plus the x plus 15 from that angle, equals 180 degrees. Solve for x, and then you can plug that back in and find all the different angles. When we get to problems like this, it's going to be a little bit more complicated because you need to use everything you know about angles for these. Let's start with this triangle over here and see if we can find any of these angles. We're given that this one is 50, but we're not given either of these. 2 and 3 are vertical angles, so we know that they're equal, but we don't know either angle. But we do know this angle here is 125, and that since this is a straight line, 125 and angle 2 have to have a sum of 180 degrees because they're supplementary. So if this is 125, that means angle 2 must equal 55 degrees. If angle 2 is 55 degrees, and I told you angle 2 and 3 are the same because they're vertical angles, then angle 3 must also be 55 degrees. Now we know that angle 2 is 55 and this one is 50, so together that's 105, and we know with angle 1 it's got to equal 180, so 105 plus what number equals 180? Well, angle 1 must be 75 degrees. Now we're going to continue to work our way around the shape. We said angle 3 is 55, and we see this angle here is 85. So 55 plus 85 is 140, which means angle 4 here must be 40 degrees. Since 4 and 6 are vertical angles, angle 6 must also be 40 degrees. But then let's look at angle 5. We don't know what its vertical angle is, but we have another straight line here. And since angle 4 is 40 and angle 5 is supplementary, angle 5 must be 140 because they have to have a sum of 180. So now we know angle 6 is 40, but we don't know 7 or 8. Well, let's see if we can use this. This is 65 degrees, and it's a vertical angle with angle 8. So angle 8 must also equal 65. So if this is 65 and this is 40, together that's 105, which means angle 7, what did I just say, 105? So angle 7 must be 75 degrees. And then we see angle 8 and angle 9 are also supplementary because they make a straight line. So if angle 8 is 65, that means angle 9 is 115. And so when you have shapes like this, just work your way through the shape. Look for vertical angles, look for supplementary angles, as well as triangles that you know must have a sum of 180. In this, we're told that triangle DEF is isosceles with base, oops, we didn't write the base. So the base should be DF, because the shape looks like this, DEF. When you know that DF is the base is the one side that's different. So we know DE is equal to EF. And we're told that DE is 4x plus 15, and that EF is 2x plus 45, and DF is 3x plus 15. And we want to find the lengths of each side. Well, if we knew the perimeter, we could add up all the sides and set it equal to the perimeter, but we don't. But what we do know is these two sides are the same, so we can set them equal to each other. 4x plus 15, that's DE, is equal to 2x plus 45. We subtract 2x from both sides and subtract 15 from both sides. We get 2x equals 30, so x equals 15. And then we just plug that in. 4 times 15 is 60, plus 15 is 75. 2 times 15 is 30, plus 45 is 75. We knew those should be the same because it was an isosceles triangle. And then 3 times 15 is 45, plus 15 is 60. So there's all the side lengths of our triangle.